Dear students, welcome to the next lecture of electrical measurement. Now, in this lecture, we will talk about the characteristics of instruments. So, there are certain characteristics like accuracy, precision, resolution. Okay, so we'll try to discuss them one by one. So, first of all, let us discuss accuracy. So, what is accuracy? That is, what is the meaning of the accuracy for an instrument? Okay, so we can define the accuracy in very simple terms, that it is the closeness with which an instrument reading approaches the true value of the quantity being measured. Okay, that is the it is the closeness with which the instrument reading approaches the true value of the quantity being measured. Okay, so that means that the closeness of any observed value with the true value defines the accuracy for the instrument. Okay, that is, if the measured value is more close to the true value. Let us suppose there are two different instruments, and if you measure the value from one instrument, it is more closer to the true value than the other instrument. For you can say that the observed value is not close than the first one. So we will say that the first instrument is more accurate than the second one. Okay, let us take an example. If there is a voltmeter, okay, and it indicates 100 volt, and it is also given that there is an error of 1% in the instrument. Okay, so that means that if this voltmeter gives you the value of 100 volt, and at the same time it is having an error of plus minus 1%. Okay, so that means that the measured value can be just is somewhere, can be supposed to be somewhere between 99 volt and 101 volt. Okay, so that means that the accuracy of this 1%, it actually defines how close the measurement is to the actual measured quantity. Okay, so this is the meaning of accuracy. Now let us move to the second characteristic, which is the precision. Now the precision with which the measurement is made is not the same as the accuracy of the measurement. Okay, but we can also say that accuracy and precision are somewhat related. Okay, so what does precision mean? So we can say that the precision is actually used to indicate the consistency or reproducibility of the result. Okay, so it actually shows the consistency of the measured results or the measured values. That is how the you can say the values are consistent. Okay, so now by saying this consistency of result, we actually mean the reproducibility of the different values of measurement. Okay, suppose you have to measure the let's suppose 5 volt from any given instrument. Okay, and if you take 5 different readings, so sometimes if you get 5.1 volt, 5.2 volt, okay, 4.9 volt, 5.1 volt, 5.1 volt, so this is a cluster of readings. Okay, this is a cluster of readings. So if all the 5 times, suppose this may be the case also, if all the 5 times you measure this result and you get the value 5.1 volt, okay, or in any one last case, let us suppose you get 5.2 volt. So if you just compare these two different sets of reading, so in this set you can see that you are able to get 5.1 4 times out of 5, whereas in this set of readings you are only getting it for 3 times. So we will say that this measurement is highly precise as compared to this one. Okay, so that is the meaning of the consistency of result, that is the results are consistent, you are getting the same value again and again. Okay, so high precision actually means a tight cluster of repeated results, while low precision indicates a scattering of result. Okay, so if the precision is high, then this means that there is a tight cluster of repeated results. On the other hand, if the precision is low, then it means that the results are scattered, or the measured values that you have measured with the instrument, those values are scattered. Okay, now having discussed both accuracy and precision, what you conclude? So you conclude from here that if an instrument is accurate, then it will be precise also. Okay, it will be precise also. So what I am trying to say, that accuracy for an instrument means precision, isn't it? That is, if for any instrument we say that this instrument is accurate, then that same instrument will be precise also. Okay, because obviously if it is accurate, then it will just give you the consistent results. Okay, although the vice versa cannot be true. If an instrument is precise, then it can have some error. Okay, so that is why the vice versa of this statement is not true, but accuracy for an instrument will mean that the instrument is precise also. Okay, so what we have studied in accuracy and precision, accuracy is just the closeness of the measured value with the true value, whereas the precision will mean the consistency of results. Okay, that is how close the successive measurements they differ from each other. Okay, so precision is a measure of the degree to which the successive measurement differ from each other, and sometimes the term precise means sharply or clearly defined. Okay, so the term precise means precise means sharply or clearly defined. Okay. Now let's move to the next characteristic, which is the resolution. So what is resolution? So we can define resolution to be the smallest measurable input change. If you increase the input to an instrument from some arbitrary value which is non-zero, so it will be observed that the output does not change until a certain definite input increment is exceeded. Okay, so this increment is called as resolution. So I will just write it down here, that if the input to an instrument is slowly increased from some arbitrary value, okay, which is non-zero, it will be observed that the output does not change, the output does not change until a definite input increment is exceeded. Okay, so this increment is called as, this increment is called as resolution. Okay, so I hope this thing is clear to you. Simply we can say that this is the smallest measurable input change. Okay, next is the threshold. Now there is some difference in the resolution and threshold. If the input is gradually increased from 0, then there will be some minimum value below which no output change can be observed. Okay, so this is known as threshold. So again you can write down here that if the input is, if the input is gradually increased from 0, there will be some minimum value, there will be some minimum value below which no output change, no output change can be observed or detected, whatever you may want to call it. This is known as threshold. Okay, so there is a difference between the resolution and threshold. In resolution, actually, resolution defines the smallest measurable input change, while the threshold defines the smallest measurable input. So these are certain characteristics of the instrument: accuracy, precision, resolution, threshold. There can be some other characteristics also, like the there is hysteresis, sensitivity. Okay, so but most of the time uh, these are the important characteristics. Okay, so now you go through all the characteristics which have been discussed here. This is all in this lecture, and thank you very much. We'll meet in the next lecture.